Hey class, Mr. Moedin here with a help video regarding the intersecting chord theorem. So right at the end of class, depending on what day we met, we saw something like this. I'll try to draw it the best of my ability. We saw that when you have two chords intersecting, they create these four pieces, and they interact with each other in the following way. So if let me zoom in here a bit, if I call, for example, this part of the blue length A and this part of the blue length B, and if I subdivide the red length into C and D, then through similar triangles, what you can find is that A times B is going to be the same as C times D. So this is the guiding principle for this entire set, that the product of the individual parts of the chord will equal each other. So for the first two here, all we've got to do is simply apply that concept. So here you'll notice we have x as one part of the chord and 10 as the other. So that says 10 times x will equal whatever 16 times 15 is, because that'll be this and this. So 16 times 15 is 240. So 10x equals 240, and hopefully you can see from there that just plain old x would equal, this is a blue length, dividing by 10, plain old x would just equal 24. And it's really as easy as that. It basically boils down to, do you understand and can you apply this concept that intersecting chords cut each other in this proportional manner with similar triangles? Looking at number 11 here below, once again, very much the same idea. This and this will give us 6x. 7 times 12, I believe, is 84. So that's this times this, 7 times 12. So divide both sides by 6, 84 by 6, and we get 14. So x is equal to 14. Now, the last example I'm going to show you is a little more complicated. We've got to find the length of segment SQ, and we've got to do so using a little bit more algebra. So we're going to do two of these, actually. Number 13 says, find SQ. Well, once again, the same principle holds true. 24 times this is going to equal the same amount as 5x plus 1 times 21. So 24 times 2 plus 4 plus x, sorry, 2 times 4x, 2 plus 4x, excuse me, is equal to 21 times 5x plus 1. So this is simply applying the same concept here in a little more algebraic context. Well, you may remember that to simplify this, we need to use the distributive property. So that would be 48 plus 96x is equal to 105x plus 21, once again distributing. Gathering my terms all on one side, I'm going to move this 96x across. And 105 take away 96 should give me 9x is equal to, so I'm going to quit the color coding here. 48 minus 21, I'm going to get 27. Divide by 9, and x is equal to 3. Well, that's part of the way. We still got to plug in x to find the length of SQ. So we simply take this value and plug it in. 3 5s will give me 15, plus 1 is 16. So to find SQ, simply add 16 and 21, and what you'll get is 37. I believe 20 and 10 will give me 31, plus 6 is 37. So there you go. So quite a bit there, but just an algebra practice, and you should be okay. We'll do one last one here. Try to get this camera to cooperate. Whoops. All right, one last one here. Once again, the same basic principle we've seen several times now. We have 4, we have x plus 3, so that's 4 times x plus 3. That's going to be in the same quantity as x plus 1 times 5. So once again, distribute here. So black 4x plus 12 is equal to, distributing here, 5x plus 5. And gathering like terms, subtract 4x. Give me 1x, or just x, subtract 5, and I get 7. So don't want to stop here. You got to find dB. dB is this entire length. Part of it's 5. X is 7, so this whole length is 8. 5 plus 8 famously is lucky number 13. Hope this helps.